Dave again here with another question from 5.2. We're going to be describing ideal and non-ideal ammeters and voltmeters. In this question we have two 6 ohm resistors connected in series with a 6 volt cell. A student incorrectly connects an ammeter and a voltmeter as shown below. By incorrectly they mean they've connected them into the circuit in such a way that they won't function as they should. The reason they won't function as they should is because ideal voltmeters have infinite resistance. If you put an ideal voltmeter in series with your circuit, it's going to totally block current, which means that no current can flow through this circuit. Ideal ammeters have 0 resistance, which means that if there was a current, and there won't be, but if there was a current, then all of it would get pulled through the ammeter and none of it would go through the 6 ohm resistor. So basically by putting the ammeter in parallel and the voltmeter in series, we've completely broken the function of the circuit. And that's not what measuring devices are meant to do. Measuring devices are meant to enter the circuit without affecting the circuit. But because we've put them in wrong, what will they read? Well, if the voltmeter has infinite resistance, then no current will flow. If no current flows, then the reading on the ammeter is going to be 0. So we know that it has to be either A or B. Now, will the reading of the voltmeter be 0 or will the reading of the voltmeter be 6? That's a bit harder to answer. First, you might think V equals IR. I is going to be 0, therefore V is 0. And so you might say the voltmeter reading will be 0 as well. Well, we have to be a little bit more careful about this circuit. If I say V equals IR, I need to be clear about what portion of the circuit I'm talking about. Let's talk about this particular resistor. It might have a voltage across it, and it might have a current through it, and it has a resistance, that's for sure. What we do know is that the current through it is 0, which means that Ohm's law tells us that the voltage across it will be 0. It will consume no energy. That doesn't mean that this particular point has a voltage equal to 0. It means we lose no voltage going across this resistor. We started with 6. We lose none going across, so we wind up with 6 right here. Same story here. There's no current. Since there's no current, it doesn't take any voltage to get across. And so this point is also 6 volts. This point is 6 volts. This point is at the back end of our EMF of our cell. This point's going to be at 0 volts. The voltage read by the voltmeter is the full 6 volts of the battery. So the answer would be B.